Well, today's topic is actually a couple of things which we skipped over in our previous discussions of Java, since they didn't fit any place in particular. So we'll start with layout. And in our earlier discussions about GUI applications, we talked about how to put up a panel and draw graphics into it. And then we talked about how to set up event handlers. And then we talked about how to put up these widgets, buttons and text controllers and table controllers and all this sort of thing, and put them up and access them and get them to display the data we want. The thing we skipped over is how to nicely arrange them on the screen so they're where we want. And there are a number of facilities in Java for doing this. One of them is all of these layout managers. And the problem that layout managers more or less try and solve is how to arrange the set of widgets which you want so that they appear nicely on the screen, or at least predictably on the screen, in a variety of screen sizes or a variety of window sizes. So if you nail down the size of a window, all right, then you can pretty much absolutely decide where to put your components. Just size them by using and position them by using the set bounds on the component. For set bounds, you can basically set where you want it to be and its width and height, and then that locks it down. Now the trouble is, if somebody shrinks the window, it'll just cut off the middle of your application, and if somebody grows the window, your application will still be stuck in this little corner. And you might just lock down the size of the application, and that is sometimes okay, but if somebody has a small screen, and you make your application too big, only that much is going to fit on the screen, and it's not going to be very useful. So to attempt to reconfigure the placement of widgets kind of dynamically and rescale them so that the application looks nice at a variety of sizes is what these layout managers are trying to do. And it's a difficult problem, and it must be admitted that they do them with mixed success. So sometimes you just have to drop back and punt and nail down the size and nail down your widgets. But nonetheless, we'll go through some of these facilities and the different ones, because there's a variety of them, and it's hard to get your mind around what they all do, but hopefully we'll do a demonstration of all of them. So the first one is the flow layout. Okay, the flow layout is the default layout of JPanel, and it has the following algorithm. If you have a window and you start to add stuff, add elements, it starts to arrange them in rows, and it fills up the first row. And then when it runs out of space, it fills up the second row, and then it fills up the third row. Okay? So it basically tries to arrange them in rows where the rows increase downward. Now, the justification is a little weird because the rows are top justified, but the widgets within each row are center justified. So I think I have this one set up. Let's do this. I was fooling around. And compiler up.
Do you know if that flow is fixed or if internationalization can change the way the flow works?
In what way? You mean make it flow like
from the bottom, because you read the other
right.
The other way.
Right. Well, remember, flow layout's not really the layout text; it's the layout widgets. Right. So that has, the internationalization would more be concerned with what the text is in the buttons and what direction the text draws in the widgets. But it's true, you might have a completely localized layout. You might need a different layout for each locale. So here I've just allocated to show you what these things do, a bunch of buttons. and different colors so you can see them. And this is how, if you throw these into a flow layout, what they're going to look like. And if you grow the window, they kind of try and fill up that top line. And then as you shrink the window, they all get squeezed in the middle, and you can see they're all still centered, and then it just starts to clip. Okay. So, what's the blue one? I don't know. Probably Sneezy, but no, Sneezy's over there. Well, then I don't know. I don't know. I find I know only a subset of the dwarves and reindeer, though I did get all of the TAs, so I should be. All right. So that's the flow layout, and that's kind of your default layout. Not very flexible, but gets you started. Yes.
What happens if you have one component in a row that's tall, so that it would cut
Right.
the other?
It sizes the components to be basically the size of the rows is the size of the biggest component in the row.
Okay, so you'd have a
Okay.
gap on both.
Right. So you'd get something that looked like button, button, button.
Automatically at the top of the row rather than.
Are they centered in the row? That I'm not sure of, actually. I don't know whether within a row they are.
I thought that's what
Oh.
you said.
No, they're centered horizontally in the row. They're centered horizontally. If you have a big row, I'm not sure whether, how the individual ones align within a row. You'll have to try that experiment. All right. So the next layout, which I find very puzzling, is the border layout. This is the default layout of JFrame and the content pane that you get out of JFrame. And the idea of that is, instead of just always having things on the top, they divide the screen into ranges, basically like this, and they label them as directions: north, south, east, west, and center. And then when you add components to this, you pick a direction. In the add command, there's a 2-argument add command, and the second argument is which direction you want to put the component in. So if you want some on the top, you would set it to be north. Set some on the south, you'd want it to be south, and wherever you want the component to be. One thing I should say about how you change layouts, it's pretty straightforward. First, you have to create a new layout. A layout is actually an object in itself. So you would have to create a new border layout. If you wanted to set it something that wasn't default to border layout, and say, this may not work. I don't think layout is actually a class, but I'm being lazy. And then you would take your frame, or your panel, or whatever, your container, and do a set layout of the layout that you wanted. All right, so I will go into my program and come down here, and I will set the layout. I've already created a border layout up here, and so I'll set the layout to that. And now I need to add the buttons in a direction. So what I will do is add them in the center. All right, so I'll try recompiling that. Fingers crossed, everyone. Oh, null pointer. Oh, sorry. I have so many of these little things that it's hard to keep them all straight. That one should do the trick. Ah. Not quite what one would expect unless you've tried it and already been screwed. The odd thing about the border layout is that it takes any widget that you put in there and sizes it to the maximum size of everything it has. Okay? So in this case, you're putting something into the center, and it says, wow, the center, there's nothing in all these, so the center I can grow to out here. And now I just have this button, so I size the button as big as that so it grows. And then if you put something else in, it says, oh, I'll just put it on top of the thing that you just put in. So here we have 11 buttons all on top of each other in the center layout. So this is, right. Dimitri is our last button. So this is not very useful. So let's see what happens if we, all right, here's another example, I believe. This one is going to cycle through, okay, instead of trying to put them all in the center, it's going to cycle through north, east, south, west, center, northeast, and try and put them in various places. So maybe at least we can get a nicer thing there. Well, you see, it's kind of cute. No, that didn't do what I wanted to do at all. Oh. I'm sorry, I just enabled the wrong one. We've got a lot of layouts to do, so. Layout is one of the most tedious. Okay, well this, if nothing else, gives you a nice idea of what it thinks the north, south, east, and west are. Okay, and it basically, since I have 5 of these, since I put one, cycled through and put them in each section, it said, okay, I have to size all these guys, but then it still grows all the buttons to be the size of the sub portion of that, and then it just again puts them on top of each other. So we have 5 buttons out of 10 instead of 1 out of 10, so we're making progress. So how do you make this thing useful? Well, what you end up having to do is put containers into each one of these guys, and then put your buttons or whatever widget you want into the containers that are in these things. So,
if you just have a north and a center, does it get rid of east, west, and
yeah,
south?
it'll grow them and
How do you decide how to size the edge ones, northwest, east, and south? I would have thought that south, north, west, and east, they would have all been
equal size? Well, the picture you saw there, since all those buttons had the same size constraints, is kind of its natural idea of how it wants to size them. Okay, so it tends to make kind of a stripe here, stripe here, stripe here, stripe here, based on probably the height of the buttons, the width of the buttons, and then what's left goes in the center. So it kind of minimalizes the edges, and then fills everything else with the center. So somewhere here, I have something that this is programming by subtraction. Grid layout 2.2. Wow, that's pretty hairy. All right, so what I'm going to do here is create 5 panels, put the panels in, cycle through all the north, south, east, west, put the panels there, and then down here I'm going to run through and put the buttons in, cycle through and put them in the panels. And this just is some arithmetic to put them, scatter them among the panels. So if this compiles, I'll be impressed. All right. Now we sort of have something. We have, these are our north layouts. These are our south layouts. Here's, I'm sorry, east and west, right?
West and east, actually.
Right, north, south. And then in the center here, it's justifying them on the top and doing a flow layout in there. So if I do that, these guys here are my center group. So let's see if it becomes a little more interesting to do it that way. Okay, here I've got them all packed. You can see the north ones, south ones, east ones, west ones, center ones, all piled up there. So that is the border layout. The book seems to think it's a good idea, and I don't know. So the next one is the grid layout. The grid layout is kind of cute for some applications. What it wants to do is take your window and basically just break it up into a set of equally spaced rectangular regions, and you tell it how many across you want, say 4. Well, say 3, and how many down you want, and it breaks them up into even regions. And then as you do adds, you just go about this and add components, and it fills them up in this order. Okay? So if we get rid of all of our fancy stuff, and we get rid of our panels, and we just go back to a very generic add buttons, and then we change our layout from border layout to grid layout. Ought to do the trick. So let me show you where I made my grid layout up here. I did grid layout equals new grid layout of 3, 4, which I think is going to give me 3 rows of 3 across and 4 down. So 4 rows and 3 columns. And okay, I guess I got the opposite. 3 rows and 4 columns. And as you grow this thing, all the individual pieces tend to grow and resize. And it just maintains this grid thing. And if one of these was bigger than the other, it would, pick the cell size to make the largest one you have comfortable, and then try and fit all and grow the rest of them in to fit. So this is kind of cool if you really have something that is a even grid layout.
A bunch of balls. Yeah.
Right. A bunch of balls, for example, in a game. That's good. Now, sometimes you don't have a full grid to fill in, so you do something fancier. I mean, the ball game is a good example for that. The calculator example in the book is a good example of that. Maybe if you're doing some kind of fancy active calendar thing, you could lay out all the days like that.
Do you know how, when you don't fill it with all the positions, how it decides to position them? Because I remember Donna and I were looking at that with the balls. If we had it, maybe we only had 9 elements that went into it, but it had 59 spots.
Right. By default, when you do the adds, it fills them across like this.
Actually, it didn't seem to do that.
It didn't seem to do that?
No, that's what your notes say, but
right.
It seemed to do like. I don't know, how did it? Is Donna there? No, she's not there.
Oh.
It seemed to. It did like 2 columns of, like when we had, I think, set it up to be a 10 by 10, and we only filled in like 15 elements. It did 2 columns. One was 7 and one was 8. And that was it.
I'm surprised.
I did my ballgame that way, and it filled it in.
Yeah, I'm surprised. And basically, here I only put in, I had 12 squares, I put in 11 things, and, that's the square it left blank. So, I don't know. Though it does depend it's entirely dependent on the order you put them in, too. So, but I'm surprised you had that effect.
It was on her code, so I don't
Yeah.
know if there was anything
So.
additional that she had in it.
Okay.
So Dave,
Yes.
earlier you added a grid layout to the border layout, right?
Right.
So that you can kind of layer them.
Right, you can put, what I actually did, I didn't add the grid layout to the border layout. What I did was make a border layout. Okay. And I put panels in each one of these, all right? And then I added grid layouts to each one of the panels, which then laid out the buttons in each one of the panels using grid layout. Okay, so you add layouts to containers, and you can then put containers in containers. So that's how you build up these things, actually.
So this last time you didn't specify the size of the grid, you just...
No, this one I did when I created it up here. I created a bunch of grids to play with up here, layouts to play with.
Just to satisfy my curiosity,
Yeah.
do that grid layout with like 5, 6, something larger.
All right.
So that... Just to see what it does.
It's not going to be happy with that, but that might be too big.
Yeah, that's like one row.
Yeah.
Like 5 by 7.
Let's do 5. Okay. And well, that's odd. That's still 3 by something.
Yeah, it doesn't do...
Huh.
Did you change something down below already? I think you changed something.
Oh, did I? No, that should be fine. So, grid layout 5, 7. Yeah, it's not giving me 5 no matter what. That is peculiar. It's not giving me either. It's just ignoring my dimensions, which is a bit annoying.
Something similar to that. It looked like it broke it up into what it thought were the most even breakups. But how it decided to do that, it looks like that, I think, was...
Yeah, I think it's trying to be a little too smart.
Yeah, maybe. Yeah, maybe it's factoring my number of things. Wow.
What it does is it starts off doing what you told it to do, but then when it runs out of things to put them in, it says, oh, stop. That's a 7 by 2, not a 7 by 5.
All right. So, yeah, it looks like it's trying to factor and be too smart. So it's, well, that's pretty lame. That's pretty lame. Well, again, good reason not to use a grid bag layout. So our next layout is the box layout. The box layout will be most familiar to you if you are a fan of tech. Anybody here a fan of tech? Okay, well, the model of box layout is kind of traditional page layout for documents. So if you have a page, the idea is to take your page and break it up into boxes in one dimension, okay, and then break these boxes up maybe into boxes in another direction, and then so on. You can break these up. Okay, this is kind of how you do page layout, and how something like tech would do page layout. At the highest level, each one of these vertical boxes would be paragraphs, and this one might be a box with a a picture here and some text over here and blank space over here. And each inside a paragraph, you have a bunch of horizontal boxes where things are laid out horizontal, each one of the words, and so on. So it's just dividing. You basically divide the thing into vertical regions, and inside the vertical regions, things are laid out horizontally, and vice versa. So there's basically two kinds of boxes, H boxes and V boxes. I think they're called something different in Java, in the Java layout, but that's shorter to do, and this is what Tech calls them. In H boxes, things are laid out next to each other in a horizontal row. In V boxes, things are stacked one on top of each other in a vertical column. One of the nice things about this layout scheme is it also allows you to put in glue and spacers. So
Are those from Tech, those conventions of glues and struts?
Screws and struts, yeah, I think they're from page layout ideas. So a strut is basically a fixed space between two things. You can say I want to allocate so many pixels between two things. And glue is stretchable space between two things. If you put glue between two things and then stretch this area will grow to take up the slack. And so your individual boxes don't have to resize. So let's see if we can demonstrate that in here, maybe. All right, so I basically made a pile of boxes. I made 3 horizontal boxes. So let's see what my layout is trying to be. I made 3 horizontal boxes, and then I made a vertical box, and then I stacked the 3 horizontal boxes in my vertical box in the following way. So here's my vertical box, and I put HBox1 here, and then I put a vertical strut of 50 here, which is fixed width. Then I put box 2, horizontal box 2, and then I put some glue, and then I put box 3. Okay, being a good C programmer, I labeled them 0, 1, and 2 here. But so this lays out all of our boxes. And so coming down here into my thing, I first have to get rid of that. And do I have a box layout? They have a series of utility routines, which is they have a class called box, which is essentially a panel with a box layout, and then a bunch of utility routines to put them together, like create horizontal box, create vertical box, create vertical glue, horizontal glue, etc. This is more or less equivalent to creating a JPanel, creating a box layout, and setting the panel to the box layout, but it saves us some typing. So, I have this thing called doBox, which is going to create a VBox. And now I need to add buttons to this thing. Well, maybe that will do the trick.
Do you want to add 11 boxes? Is that, you've got it inside your for loop,
Oh, that's true. Do I want to do that?
10 boxes.
Let's see how I do this. I want to make that and that. So no, I want to do that outside of. And so where am I adding the buttons? Set those, set those. This is so complicated. Box center. Add buttons of I. The do box is this thing up here, which is just, it's basically doing this and then creating it's returning a VBox. So I guess what I want to do is something like, right, I want to come up here and add do box to center. But now my question is, how did I get my buttons in there?
Yeah, hang them there.
Oh, okay, I've already built them. Okay, good. Good. No problem. So I don't need to do any of this stuff at all. I knew at one time all this worked. All right. Oh, null pointer exception add. Do box center. Oh. Well, we still need this loop to create the old buttons. And we probably want to set their background colors too. Okay. So here's my first row of buttons, and I just cycled through and added the mod 3. First row of buttons. It's flow. Did I do a flow layout? I forget what I did in this individual rows actually. Oh, I know what I did. I was fooling around with struts and stuff. So here's some random struts. Here is my a strut. Here is my glue. So, okay.
What does the glue do?
The glue is the thing that stretches. If you look at how I set this thing up in here, when I cycle through all my buttons in this setup loop, and then I add them to the button index, the box that's button index mod 3, just to sprinkle them around, and then also randomly. I put in horizontal glue into each one of these horizontal boxes. Okay, so that's where these spaces come from. Here, horizontal glue, here. You basically went 1, 2, glue, 1, 2, glue. I don't know why that one went out, but glue. So, and what the glue does is it stretches, all right? Let's see, as I grow the thing, this space is glue, this is a strut. So this space here stays fixed, whereas this space, the vertical glue, grows to take up the slack.
So it just has to do with creating how much dead space you have?
Right, it's just where the dead space goes. If you want the relationship between this and this to be constant, you put in a strut, otherwise you put in glue. These are all glue so that no matter how much I stretch, this guy is always at the far right and this guy is always at the far left. So that's pretty cool.
So who came up with this word glue? It seems they're doing the exactly opposite.
I don't know. It's an old word. It certainly goes back to tech, and it might go further back to, it might be a typesetting word. I don't know, but it's certainly, the first time I read it is in the old tech manuals. So yeah, if you read how tech does things, it uses the concept of glue and also the concepts of fixed space. So okay, yes, question?
Back before I saw the error of my ways, I was trying to do the same game with the layout manager that would just shift according to the rules of the game when a component was removed, like with nested vertical boxes and glue on top that would push them down.
Oh yeah.
A horizontal box
Oh, wow.
And I was just gonna have it all work like magic.
That's pretty cool approach.
No.
Well, it ought to work if you can keep the individual panels from resizing like mad on you.
Yeah, well, right. You can set a maximum
Right.
on them, right? But the problem I had was, how do you, like, what do you call to refresh your, I mean, if you move it, it refreshes automatically. If you resize, the glue expands and fills up space. But if you just remove a panel, it's
Right.
dead gray space until you, there's this invalidate layout thing I've never really used, but I don't know.
Yeah, there is a change listener on there somewhere, but I'm not sure how to. I know it's easy to figure out how to do something when the layout changes, but you're right. I'm not sure how you reconfigure it if a call to repaint doesn't do it.
Yeah, repaint didn't seem to.
Repaint on the what did you call repaint on?
The outer container.
The content pane?
Yeah.
Ah, that's true, because that hasn't changed size, so it's just going to say, you know, I don't have to. That's tricky. That is tricky. I don't know. You got me. Still a cool idea. Okay, the final layout, or second to final layout we'll talk about is the grid bag layout. And if the box layout uses the standard page layout metaphor for laying out horizontal and vertical boxes, the grid bag layout uses the standard table layout mechanism. If you've ever laid out tables in TeX or laid out tables in HTML, it uses that algorithm where essentially you take your space, and again, you're going to divide it into rows and columns. And you do have to have a even, you know, it's not an irregular thing. It is an even number of rows and columns. But the rows are not necessarily equal size, and the columns are not necessarily equal size. But you have an initial thing layout like this. But unlike the grid or the, what was the other one? The grid layout, each component can take up multiple sections of your table. All right, so you can have one row that spans the entire table, and then another one that's, you know, uses each of the grid blocks, one that takes up two. Okay, so, and you can have them take up multiple numbers of vertical as well as horizontal. So. And the advantage of this is that because it's underlying this grid, okay, this even grid, and you're taking up subsections of the grid with your components, you can keep components aligned within rows and across vertical and horizontal divisions. The problem with doing it with H boxes and V boxes is everything within a given H box is aligned only with respect to itself. It doesn't know the rest of the world. So what's happening in another H box below it has no effect on it. And so if you want two rows of things that are aligned lockstep, but they don't fit into a grid box, this is the scheme you use. Unfortunately, it's massively complicated, just like laying out a table in TeX or in HTML, and but you just have to do it. So the way that you do it is to make one of these grid constraint objects. Okay, for each component, you basically need to make a grid constraint object which tells it basically where in the grid, what its starting square in the grid is going to be, and how many grid squares across it wants to be, and how many grid squares down it wants to be. And you can also set something that relatively weights, when it grows and shrinks, how much of the grid space, you know, how important it is. The book recommends setting that always to 100, so you just reduce the number of variables you're playing with. You typically have enough control here to make everything work. And then you have a fill parameter which says you can fill it in horizontal, you know, you can grow the components to maximum size horizontally or vertically. So here I made a utility method to make all these constraint objects. All right, then down here, for each of my buttons, I made a constraint object, and I put them at various places with various widths in my grid. And then we come down here, and I made a grid bag layout and an array of grid bag constraints, which, so let's see, I need to comment out that one, set my layout to GB for grid bag, initialize all my constraints, and then I need to go put my buttons in, and I need to add the buttons to the grid bag layout associating the proper constraint with each button. Okay. It's actually not that horrific to do. The difficult part, the challenging part, is you have to draw out what you want the thing to look like on a piece of graph paper to come up with all these numbers.
What are those numbers correspond?
These numbers are where I want the thing to start, x and y, and how wide I want it to be and how high I want it to be. So this one's going to start upper left and be a 1 by 1 cell.
What units are those in?
These are in grid squares.
So if you've got a 10 by 10 square,
Right.
a 10 by
Here
10
you don't, with a
square.
grid bag, you don't tell it the target size of how many across. You just put in things that say start here and start here, and it kind of sizes the thing, the grid, based on what you put in. So here we're probably going to have about a 6 deep grid, because I start things at, I start some things at location 5 and I make them height 1. Here I start something at location 2 and make it, or here I start things at location 3 vertically, row 3, and I make it double height. So let's see if this actually works. I don't even remember what this is supposed to look like.
Sizes the button to fit the cell.
It does, because I put that layout fill both. It means fill in both x and y directions. So here it's growing to the maximum dimension. So just so you can see where how this corresponds to my constraints. For example,
Those are double height buttons.
that's true. That is true. It did not seem to pay attention to my height constraints. These two here should be double height. Which one is that one? That is Donner and Blitzen. Should be double height.
Well, they may be, but it just makes you have
That's
hard to
true
tell.
too. It's hard to tell.
you have to make one of them not double height. Make one,
Or
make the first one. Make
Oh.
one or just single height. And see
That's a
if
good
that-
idea.
Yeah.
Because there's no way to know. if it's-
That's a good idea. Well, this is how you learn, is by science. No? It just does what it wants to do. Well, this is why layout is a nuisance. Let me take away that this fill business. Okay, so now it should default, I believe it defaults to no fill, despite what the book says. Okay, so here's what it looks like without. Each one is kind of centered in its own square. And if I grow them, they spread out and the like. Now, I don't know whether these things are actually taking up, as I say, 2 grid squares, but they're just so small that it's just growing them to fill in the space or what. But it does not, it certainly is not doing quite what I expected. But here, if you look at it like this, you don't see quite the gridness of it originally, but you can see that these guys are all aligned in a column. Sneezy and Rusty, I think, are aligned in a column. Blitzen is like actually centered in 3 columns, so it's a little offset. So anyway, all right. The final layout we'll talk about is the null layout. Like I say, sometimes you just want to drop back and punt and nail down your nail down your buttons to where they are, and oops. So the way to do that is to set the layout of the panel to be null, set where you want the buttons to be by hand, or set any components. So here I'm running through, and you set bounds by setting the upper right-hand corner of where you want the thing to be, and then you set the width and the height. So here my widths are all going to be 100, my heights are all going to be 30, and I'm going to increment the upper x by 40 every time, so I'm just running them down the diagonal. Okay? Because why not? So, now there's a graphic user interface. All your buttons nicely at hand to do whatever you want.
When you do the null layout, there's no resizing of it.
No, it just nails those guys down.
A sort of dialog box kind of thing, is that null layout what you do to, you have a fixed...
Yeah, if you have a fixed dialog box, the null layout is what you do. And that's, if you use one of the layout tools that you use to drag and drop and position things, at least in VB, they tend to give you a fixed layout. They just nail them down where you put them, and you have a fixed size thing, and that, to be honest, makes your life a lot simpler. Two other things for laying out components that you'll find useful for your project, although they're not layouts, there are two container panes or container types which are useful for putting other containers or collections of widgets in. I really like these both a lot. One is called JSplit pane. And what this does is it gives you, if you put it in, it gives you a way to add two containers. When you create it, you have to give it two containers, and say two JPanels, which it'll put on top and bottom and left and right, and then give you a control bar here, which is mouseable up and down. Okay, so that's very cute. The other one is JTabbed pane.
What is this control? Height?
This one, it's just lets you put the mouse on this and move this bar up and down, and resize the two halves, split the two halves the way you want. And this does that convenient thing that you always see where there's a line of tabs with labels. And you click on one of these, and with every label you have to associate another container. And when you click on one of these, whatever container you associated with it pops up in that space. So if you look at pretty much any app you download these days, they make heavy use of these tabbed containers. And I like them a lot. They're easy to use, and they make applications look neat. So, and you can put these things inside these things, so you could have a tabbed pane where one of the panes has a split pane, or vice versa. You can have a split pane with independent tabs, and then once you get this level of layout done, then you need to worry about, you finally get down to a panel here where you're whacking in some components. And that's where you have to worry about the HBox or grid bag or whatever layout. I guess I would recommend, although they're a bit of a hassle, either the box approach or the grid bag approach. But maybe that's because I've done too much tech. Okay. We have a little time left, and I want to cover two more topics. One of which is packages. We've kind of skirted the issue of packages, and there's nothing terribly fancy about it. The idea is, right now we've basically been building our applications by putting all of our files in the current directory and making up our own names and importing Java packages when we need them. as your applications grow, or as you start to import more third-party application libraries or produce yourself libraries that other people are going to import, the chances of name collision on a class increases. Okay, so Java has this class called vector that does auto-resizing arrays. If you're a math guy, you might want to have a math class called vector that does math vectors, and if you call it the same thing, they're going to get confused. So packages are just a way of grouping a bunch of classes into a namespace. All right, and so you make up a package name. Let's say I made one called Lecture 14, I think, for this lecture. And say I wanted to put my layout class into this. The layout class, instead of being referred to now as Lecture 14 or as layout, and my main routine is being just layout.main, it would be Lecture 14.layout. I think layout test is my class. Okay, so this just lets you, I have eraser problems, lets you prepend a thing to the namespace. Now, if you think about it, all you've really done is push the problem up a level, because the old problem used to be your class names weren't going to be unique among people. Now you've put them in packages, but what's going to guarantee you make up a package name that's unique? You could put your vector in, math or .vector or vector.vector or utils.vector, and then you'd be back where you started from. So Java recommends, although it doesn't enforce, the fact that you prepend some unique identifier for yourself at the beginning of your packages. And what it suggests is your domain name, assuming you all have domain names, backwards, in backwards order. So it would suggest for us maybe org.aduni. say Java course .lecture 14 .layout test. Okay, layout test is the class. My package name would be this. Okay, org.aduni.java course .lecture 14. These get to be a bit long, but you can see that is probably unique. Not many people are going to make especially if they stick to the scheme, a package name arbitrarily that looks like that. So if you were worried about people in your class, you would do Java course and your email address. Okay, so or org.aduni. your email address .whatever. So you put your organization identifier, your name identifier, and you build these up. Now to do this, to put a given set of files in a package, okay, you put the package descriptor at the top of each file, all right? And so you would just put in this command that says, I want all of these classes to be in this package. The package command has to be the first non-comment thing in a file to work. Now I could take multiple Java files and put this command in them, and they would all end up in the same package. And we have been a little free with not declaring some classes public at the top level, because we've all been working in the same class, and assumed that things are defaulting to public, but really things default to package scope. So anything you want to be available outside the package, you would have to make public. And indeed, the only thing I really want is my main class, which I do make public. And then you can just compile this as we did before, and it should do the same thing, except it's going to put this class in a package. So if I do that, it should complain.
So what does that mean? Does that create a subdirectory?
No, all it does is it tags that class file, which is still in the subdirectory, with this package. So now, when I ask it to start class layout test, like I did here, it says, there's no class layout test in this package. All there is class org.uni.javacourse.lecture14.layout test. All right? So you would think that I could type here Java of org aduni dot course dot lecture 14 dot, and that does work. But notice it does something different. It works essentially for the wrong reason because I had done something earlier. So let's fix that. The reason, what it's doing is Java maps, for some reason I do not understand, except to try and force you into this Java-centric view of the world and try and ignore the fact that operating systems exist, maps this class path into a file system path. So in order to find this class, what did I call it? Layout test. It's going to look in directory org slash aduni slash Java course slash lecture 14, and then it's going to look for that class. So I tediously created that enormously deep directory tree, and if my history is good, I should have something that copies star.class down into there from my current directory. Remember, I just compiled this stuff in the current directory, set that class, that package name in the current directory, and it created it, and it's still there. So, but in order to use it, it won't let me use it in the place I compiled it. In order to use it, I've got to relocate it in this weird directory down here. And now when I try and do it, it should get the most recent one. The old one it got was the flow layout one. Now it's the one I just compiled, the null layout one. So if you're trying to do both use packages with this namespace and do kind of organizing your source in a structured way, this can be a real nuisance because you've either got to put your source files, you've either got to basically do your development down deep, deep, deep in this hierarchy and then access it from the top of this hierarchy, or when you're organizing your source files, you have one source tree and source one for all your modules, and then you basically end up with this big, deep binary tree that you have to copy everything down in, and in order to run it, in order to use your packages. Since all this stuff is great for making your stuff unique in the entire world, but just working on your local machine can be a nuisance. We're partially saved by this, although not on this machine, by our next topic, which is jar files. Jar files are just zip compressed archive files, and they also let you add some special information that will describe the files that are in there. The nice thing about it is that you can take all of these classes that you have scattered down here, make a jar file of them, and put them in one file, and the Java command will search for them within that jar file as if this whole directory hierarchy existed without having to expand the jar file in that directory hierarchy. So you can give your classes to somebody else to use, and they don't have to make this whole directory hierarchy and expand them out. They can use the jar file because the jar file builds into it this whole directory hierarchy. So the command, the jar command, small letters, works pretty much the same as the Unix tar command in terms of its arguments. So to create a tar file, you would do cvf myjar.jar, and then file names or path names, like I could do org dot or slash star, and it would basically archive the entire subdirectory from org down into myjar.jar. Yes?
What is CVF?
CVF are just this is how the Unix tar program work. You have the command, you have a series of letters to tell it what to do, and then you have the arguments that tell it what to do. So C means create the archive. V stands for verbose, which tells it to print some stuff on the output. And F means instead of dumping the output to standard out, it dumps it to a file, and this thing has to be, most times, the thing immediately following the F. So the first argument after the F, except for one case, is the place where it puts the jar file, and then you give it the list of things to archive. Other things that can replace the C in this formula are T, which gives you the contents of the archive without extracting it, and X, which basically extracts the archive. It dumps the files in the current directory. So CVF, TVF, XVF. And this creates, as I say, jar files are essentially zip compressed archives. So you can expand them with jar, and I think you can unzip them as well.
But do you really want to like zip and unzip them all the time if you're working with the source code?
No, certainly you don't want to use jars when you're developing. You want to use jars to package up all your classes. So basically, once you've got your classes, you have to make this to put them in the right package, you have to make this deep directory hierarchy, copy all the classes down there, but you don't want the user who uses your stuff to have to duplicate this silly directory hierarchy. So then you package everything up in a jar file, and they can just use the jar file. So to use a jar file, we say Java, our normal Java command, and say our paths were there. We can say class path and somebody's jar file, and then the name of some class. Look for this class in that jar file. It will add all these things to your class path. So that's kind of cool.
I don't quite understand, by doing the jar,
Yes?
does that mean that the user, when the user runs the jar, is automatically creating those directories within their own system?
Only if you do the X. Okay? If you do it here, class path, no, Java is smart enough to basically internally search the jar file without expanding it. So if you just use the jar file, it doesn't mess up your file system. Only if you do jar XVF will it expand.
There's probably a certain amount of overhead in running that because it's got to decompress.
Yeah, but it's all startup overhead.
Is it for the minimum?
Yeah, it pulls all the things up in, yeah?
I just don't quite understand the class path parameter, and the jar file has to be put into the class path. So is that
Using this, right. Class path just tells Java where to look for all of your classes, all of the classes you mentioned, like all those java.utilities, all that. It's got to find those someplace. The default class path gives it a pointer to there. It also assumes your current directory is in the class path. This lets you put something else in the class path. Okay? So this says, look in this jar file, all the paths in this jar file for layout test. Now you could put, instead of a jar file here, just an ordinary directory. Okay? For example, if you had all of your classes down here, you could say class path org/alum dot blah 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 blah, and it would look in there for some classes. Okay? So one other cool thing about jar files is that they have a information file specially hidden within them, if you give it one, called a manifest. And a manifest, usually called manifest.mf, is a text file that has information about what sorts of things are in the archive. And to create an archive with a manifest, you add an extra argument to this jar create thing. You say jar CVFM or MF, and then after the target file, but before anything else, you put the name of your manifest file. And then you put the things you want to archive. One weird thing about the way this argument structure is done is the order of the F and M here have to exactly match the order of this file and this file. So you can say CVMF, then you would have to say manifest and jar, or you say FM jar manifest. But whatever order these two letters are in, the next two arguments have to be the manifest and the file name in the same order. It's a strange way of, you would think they would do -M manifest -F jar, but it's a holdover from the traditional tar syntax. So what can you put in a manifest? Lots of stuff, most of which is relevant to things like Java beans, which we really won't talk about much in this course, though maybe a little bit on Thursday. But one of the things that you always need is this first line that tells you what version, just manifest version : 1.0. The format of the file is keyword : value. One thing cool you can put in there is the target main class. Okay, main class tells the archive that, or tells Java that if I give you this jar file to execute, this is the class that you start executing at. So if I've made my archive down here, I can set this as the main class. And then, and this is the coolest thing, I can say java-jar, say I made this in layout test. Okay, and here it will execute, it will look in here for main class in my manifest. It'll look in my manifest for a main class. If it finds it, it'll look in the jar for a main class and start executing there. So this is, okay, if you want to package up your programs, right now your programs exist as a whole big old mess of class files, which say you wanted to give to somebody who has had a Java virtual machine. It's pretty hard to give that in a nice unit. Okay, jar, this concept lets you create a manifest, package all of your classes up. You really ought to put them in a nice hierarchy like that. But package all of your classes up into one neat package. This then you can distribute to people, and they can just run it from their command line like this. Assuming they have a good Java virtual machine, they can do java-jar, yourprogram.jar, and it'll just run. Okay? Not quite as good as being able to publish an executable where you just type the command name like you would in C, and it would run. But it's a good way to distribute your stuff. So I haven't gotten a chance to see a lot of your game program. So if any of you are feeling ambitious or pleased, package up your game program in a jar file labeled, with your name on it labeled, and send them to me, email them or something. I'd like to try them out. I might also try and convince Sarah to put one of the two of them up on the website if we have space, to, if you don't mind letting people download them, and just kind of as an advertisement of what we do, or maybe just put up some screenshots of a few. I don't know. I think that would be a nice thing to do to kind of prepare students for next time. Jar files.
Suppose you really want to do an executable instead, how would you?
Excuse me?
Suppose you wanted to do an executable, what would be the tools you need?
Oh, if you want to do, then you'd have to go get a native compiler. Okay, and something that didn't compile to .class files, but compiled down to native binary. Okay, and there's probably some of those commercially out there, but we don't have one. This machine, I would have demonstrated you this jar stuff on this machine because it's really cool, except that I discovered the jar, for some reason, did not get expanded on this machine in the right place. So there's no version of jar on this machine. So, and then trying to copy it by floppy failed. So I figured I would cut my losses, and we got to do stuff. All right, that's all I have to say today. Tomorrow we're going to talk about Java on the web, and hopefully we'll be able to do some more show and tell.